It was shortly before noon when I arrived at Washington Airport. It had been a quick trip. Only a few hours before, I had left the university campus. And now here I was, ready for the Chemical Corps assignment I had been called down to Washington for. I knew very little about the assignment, except that it was top secret. Of course, I was aware the Army Chemical Corps works closely with scientists in the industrial and academic worlds, so I could guess it had something to do with my being a professor of biochemistry. But beyond that, I would just have to wait and see. The colonel who met me at the airport told me the first order of business would be a meeting with the Chief Chemical Officer, United States Army. Then a short orientation survey of some of the key installations before getting down to work. I was glad to have an orientation because, well, in my mind, I had two questions about the work of the Chemical Corps. Questions I know a lot of people have. Questions that have to be faced up to and answered. The first question, with the development of modern atomic warfare, was there any real need for this sort of thing? After all, were CBR weapons in the same league, so to speak, as the nuclear bomb? And the second big reservation bothering me was the impression I had about this kind of warfare as something cruel and uncivilized. Was it even morally debased? Oh, I know war is no tennis match, but I think I echoed the reluctance of most people to face up to such activities as chemical, biological, and radiological warfare. Ten minutes later, along with the other special consultants, I met the Chief Chemical Officer, and the orientation had begun. Even then, the two questions I had asked myself still gnawed away, insistent, probing, always there. We were here as consultants and would do the best we could, of course. But I knew myself well enough to feel those questions would have to be answered if it were really to be my best. Well, it didn't take me long to realize no body of men was more anxious to face up to those questions than the Army Chemical Corps and the Chief Chemical Officer, United States Army.
Gentlemen, you've been asked to act as consultants on a project we of the Chemical Corps have developed, which bears on your specialized scientific and industrial backgrounds. We regard this as an opportunity to bring to bear a fresh viewpoint, an independent critical standard on a phase of our operation. We appreciate your taking time from your busy schedules to serve as consultants for the next few weeks. Now, I don't have to belabor the point here that the Army's job, together with the Air Force and Navy, is to maintain the peace and security of the United States. Our job in the Chemical Corps is to make available one set of tools for this job of maintaining peace. This set of tools consists of chemical, biological, and radiological munitions and defensive equipment. So that we'll all be thinking along the same lines, that's very...
As I listened to the Chief Chemical Officer, I began to have an idea of the vast scope, the tremendous array of military potential summed up in the letters CBR. The C of CBR, chemical warfare, involves the military use of chemical compounds. In more down-to-earth language, using and protecting yourself against the war gases. Chemical warfare also includes the use of flamethrowers, portable or mounted. Incendiary materials placed on a target from the air. The employment of obscuring smokes is another example of chemical warfare. The B of CBR is biological warfare, the deliberate use by man of microorganisms, germs, to cause disease among humans, to cause disease among animals, and to cause disease among crop plants. Radiological warfare, the R of CBR, involves the use of radioactive materials on a specific target area. This includes the fallout from nuclear weapons. Military and civilians alike may face this problem in the event of a nuclear. The chief chemical officer continued to outline the overall picture of C, B, and R. Perhaps it was grim stuff to hear, but then again, what manner of fighting a war is not? I began to see that it is all very well for some to decry CBR warfare. But the fact remains that CBR weapons and tactics are just as much within the capabilities of our potential enemies as other modern methods of warfare. We were shown evidence of their efforts in this field. Said the Soviet defense minister in 1956 at the Communist Party Congress in Moscow, quote, "Any future war will be characterized by the mass use of air power, various types of rockets, atomic, thermonuclear, chemical, and biological weapons." End quote. The warning is right out in the open for everybody to see. In the event of war, CBR is just as likely to be used against us as the nuclear weapons. The Army Chemical Corps provides assistance to the Navy, Air Force, and civilian defense authorities. As the only agency of its kind in government, the Corps must carry out the CBR research and development. It must carry out the manufacturing. It must carry out the procurement. The advantages of using CBR weapons are just as apparent to any potential enemy as they are to us. In the next few days, I was to learn a great deal about those advantages. For example, aggressor military leaders know this advantage. Chemical and biological agents cannot ordinarily be detected by the human sensory organs. You can't smell anything, taste anything wrong, but the effect can be deadly. Burrowing into the ground is the normal means of protection against explosive-type munitions. But military leaders of any would-be aggressor nation know the protection afforded by underground fortifications and trenches can be circumvented or penetrated by CBR agents. These agents are usually released in a heavier-than-air aerosol form, which flows over the ground like water, seeking and hugging the low places. The user of CBR can put a victim out of action for a period rather than maim or kill. But perhaps to an aggressor nation's military leaders, another advantage is paramount. Unlike many other powerful weapons in the arsenal of modern warfare, CBR is not a weapon of total destruction. And destruction for destruction's sake is seldom the purpose of a military attack. From the viewpoint of the attacker, the rubble is only a byproduct. The attacker much prefers to occupy an undamaged target, then control and use its productive facilities. Our steel mills and industrial plants are prized by would-be aggressors. We remember how the Soviet forces were so quick to remove industrial machinery from Germany and Manchuria at the end of World War II. To be of use to an aggressor, these industrial plants would have to be left standing. CBR weapons can accomplish this and still inflict enough casualties to win wars. Without a doubt, if it were to their advantage, our enemy might use CBR for this purpose. There, in a nutshell, is why we can't ignore CBR. The briefing from the Chief Chemical Officer was over. Now I was ready for a short, on-the-spot orientation of work in the field before starting my assignment. First stop, the Army Chemical Center at Edgewood, Maryland. Here are employed hundreds of qualified scientists, men and women, in and out of uniform, with many more that number of technicians and skilled workers. While most of the installation is off limits to the casual visitor, the Chemical Museum on the post welcomes guests. Before observing the work at the center, the colonel felt a visit to the museum would be valuable. For one thing, I got an idea of how past hostile powers had stressed chemical warfare. I saw the display counters of World War II German protective masks for soldiers. The Germans took chemical warfare seriously. So did the Japanese. A particularly interesting item was a World War II Japanese incendiary bomb carried by balloons as far as Michigan. In the Chemical Museum, there is also a display of Soviet chemical warfare equipment. But the bulk of displays deal with American equipment, protective devices and weapons, since chemical warfare became a reality of modern combat in World War I. But chemical warfare goes back a long time before World War I. Incendiaries date back to caveman days, when flame and burning coals were used to drive off the enemy. Primitive flamethrowers were used before 400 BC by the Spartans against the Athenians. The Spartans also melted down pitch, charcoal, and sulfur, so the fumes would be carried downwind to the enemy. In the year 1700, Swedish forces set up smoke screens from burning wet straw to cover deployment for battle against the Polish-Saxon army. World War I saw the first use of aircraft incendiaries with the German Zeppelin raids on London in 1915. The same year, the Germans used chlorine gas against a British rifle brigade near Ypres. Approximately 1/3 of the American casualties in World War I were caused. However, only 2% of the gas casualties died, compared to a mortality rate of 25% among the non-gas casualties. World War II incendiaries played an important role in the German Blitz of London in 1940. In the Korean War, napalm, a gelid gasoline used as an incendiary, often drove the enemy from well-entrenched positions. I thought about all this, the past of chemical warfare, as I went on to observe the present at the Army Chemical Center. In well-equipped scientific laboratories, highly competent chemists, physicists, microbiologists, and engineers explore many important lines of inquiry. Their primary purpose, to cope successfully with chemical warfare. And coping with chemical warfare means coping with chemical agents, substances employed in chemical warfare for tactical purposes. To defend ourselves against their use, we have to understand everything about them, how chemical agents are prepared, and how the munitions are prepared which will disseminate them. First, the munition is carefully worked out on paper. Then models are built precisely to scale. Pilot plants are designed to test the feasibility of large-scale production of both the agent and the munition. Hand in hand with basic research and development on chemical agents, goes the never-ending job of working up practical detection and protection devices. Devices which indicate the presence of nerve gas in the atmosphere by sounding a warning loud and clear. Telling a man agents are in the air is one thing, but he must continue to function, go on with his work. The Chemical Corps has designed a new lightweight, canisterless mask, just one of many developments in the field of individual protection. Many different types of protectors have been developed. I saw just a few of these special masks. One for military personnel, one for non-combatants, an infant protector, one for hospital cases, and many others. I saw many developments that day at Edgewood. I began to gain a sense of how the Chemical Corps does not ignore any possibility in the defense against potential CBR attack. In one laboratory, I watched a demonstration of clothes treated to protect the skin against the vapors and spray droplets of blister gases. The contrast between clothing which had not been specially impregnated and the chemically treated clothing was strikingly apparent. Drops that had soaked into the cloth before just rolled off like water from a duck's back. A surprise alert at the Chemical Center gave me a hint of progress made in the development of protective shelters. It was midway in a typical working morning when the building was exposed to a mock CBR attack. Reacting quickly, the office workers set up Chemical Corps-designed diffusion barriers. The room must be made airtight to prevent the seepage of gas into the enclosure. The diffusion board is composed of fiber and active impregnated charcoal, which filters out CBR material, while at the same time allowing the carbon dioxide and moisture created by the occupants to diffuse outwards. Within 2¼ minutes, the room had been made safe from CBR contamination. The diffusion board is, again, just one of various Chemical Corps approaches toward the problem of protecting our population in the event of all-out war. The medical problems and implications of chemical warfare present a tremendous challenge to the doctors, researchers, and scientists at Edgewood. To defend against CBR warfare, one must know about CBR warfare. How, for example, the vital functions of the human body can be affected. Biochemists and biophysicists spend long periods of intensive work alone in a laboratory or as a part of a coordinated group effort. In clinical and physiological laboratories, doctors investigate the effects of chemical warfare agents on the human body and develop medical treatment to counteract these effects. Yes, to defend against, one must know, and the roads to knowledge are varied. In one laboratory, a striking experiment of the effects of a certain harmless chemical compound took place. A cat's reaction to the presence of a mouse was just about what you'd expect at first, a typical hunter's instinct. A harmless chemical agent was introduced. The cat's behavior became temporarily timid, frightened, defensive, contrary to his normal behavior. The head of a group of research chemists explained to me some of the means of protecting against chemical warfare agents and how his group prepares chemical treatment kits for use in the field. A few minutes later, I was shown a demonstration of one of the many ways developed for the detection of chemical agents in water and food. Medical researchers at Edgewood work constantly in cooperation with the Army Surgeon General on the development of means and methods to counteract their effects. The primary purpose of the research work at Edgewood is successfully coping with chemical warfare. But peacetime benefits have also come out of the work of the Chemical Corps. In researching for new chemical agents, intensive studies must be made on how these chemicals affect the human body. Just as an example, Chemical Corps researchers discovered that one of the body effects of the nitrogen mustard war gases is a reduction of the white blood cells. Why not then study the use of these gases for treatment of those forms of cancer where there is an abnormal increase in white blood cells? This line of inquiry has led to work of value in the treatment of leukemias and certain cancerous growths. Another example, an ointment developed originally by the British to counteract the effects of lewisite and other arsenical war gases has been found to be an effective antidote for many of the common metal poisonings in industry. Studies of nerve gas effects on the body have also led to the adoption of a more effective form of artificial respiration. Fresh air is forced into the lungs of a person being revived directly through a special mask designed by the Chemical Corps. Glaucoma is an eye disease which can now be treated by a method developed by Chemical Corps medical scientists. Even in the short time I was at Edgewood, it became clear to me that there are few branches of the military with activities more readily reflected in peacetime benefits than those activities carried out under the name of chemical warfare. In all, more than 300 contributions of medical and agricultural significance have been made as a result of Chemical Corps research, much of it at the Army Chemical Center. Not very far from Edgewood, in historic Frederick, Maryland, are the biological warfare laboratories. Many well-qualified scientists are employed here, backed up by an even greater number of technicians and skilled workers. These men of science are doing basically the same type of work that is being carried out in other government, university, and industrial laboratories, a combination of medical and public health research. While I was at Fort Detrick, I was able to follow part way through an experiment to determine the effectiveness of an agent. Volunteers are important to the testing picture. For many years, information has been needed on the effect of a biological warfare attack on man so that we can have a better understanding of how to defend ourselves against it. The volunteers were a picked group. They had received psychiatric interviews to determine their maturity and reliability, as well as mental outlook. Medical histories and laboratory checks on the volunteers had been extremely stringent. Any history of a chronic disease, any allergic reaction or nervous disorder was a cause for rejection. Volunteers were given the opportunity to drop out at any time with no stigma attached. I was to watch the progress of the experiment from the control room. The volunteers had been positioned in cubicles on the outside of the test sphere, a hollow steel ball 40 feet in diameter. The sphere is so designed to enable a controlled aerosol, a cloud of biological warfare agents, you might say, to be generated within it. Through a series of controllable valves and a face mask, it was possible to expose the person in each cubicle to a measured volume of a biological aerosol from the sphere. I said before I was able to follow part way through the experiment, the final part. As was expected, the volunteers were temporarily incapacitated, but within a short time, they were up and around, completely recovered. They had the satisfaction of having played an important part in obtaining information which would immediately be given to the Public Health Service to bolster our defenses against disease. Even when out of the laboratories, over coffee at lunch, the shop talk goes on endlessly. For here are people who are enormously interested in their work, both because of its importance to the national defense and the many contributions to the cause of everyday human welfare. An intensive military research and development program has resulted in many scientific findings beneficial to mankind. One area of contribution is development of methods for the rapid and accurate detection of disease-producing agents. Work at Detrick has also contributed the knowledge of the control of airborne disease-producing agents. Progress has been made in working up immunity in human beings and animals against certain infectious diseases, as well as their treatment. Methods have been developed for production and use of certain vaccines. One of the more recent developments at Detrick is a perfected vaccine for controlling industrial anthrax, an infectious and usually fatal disease of cattle and sheep. Still another accomplishment has been the development of protective devices for the safe handling of disease-causing microorganisms and their harmful products. Special photographic techniques have been designed for the study of airborne microorganisms and laboratory safety procedures. Filtering devices have been perfected, which will aid the food industry in rapidly determining the bacteria count of their products. And just another example, the now familiar weed killer, 2,4-D, was a byproduct of biological warfare research. From Fort Detrick, I went by train to Anniston, Alabama, where Fort McClellan, home of the U.S. Army Chemical Corps Training Command and Chemical Corps School, is located. I sat in on a few classes. I noticed, along with Chemical Corps personnel at the school, were representatives of the other services. There are representatives of public health, civilian defense, and other agencies. Officers of the military forces of friendly foreign nations are also present. I noticed, too, that a heavy emphasis was placed on the R in CBR, radiological warfare, along with learning how to deal with the atom in peacetime. A steady program of laboratory exercises teaches Chemical Corps students the fundamental procedures involved in the handling of radioactive materials. calibration exercises train the students in the maintenance of the radiation detection devices they will use in the event of a nuclear emergency. At Fort McClellan, the techniques of survey and monitoring are taught to selected non-commissioned officers who will return to their units as instructors in these same subjects. Techniques used were developed by the Chemical Corps during bomb tests in Nevada and the Pacific. Practice gives the students the confidence and know-how they need to cope intelligently with any nuclear emergency that may arise in the future. Students have the opportunity of visiting atomic testing grounds, where they monitor radioactive fallout by ground and air means. Also at Fort McClellan is the first Radiological Safety Support Unit. A mobile organization, it is on a 24-hour standby alert, ready to go anywhere in the world to provide technical assistance in dealing with radiation hazards. I had one more visit to make before returning to Washington, to the large test site of the Corps at Dugway Proving Ground, Utah, where the Chemical Corps holds field trials to determine the effectiveness of CBR munitions. Trial runs conducted here duplicate the actual conditions in the event of emergency. Sampling devices positioned throughout the test area yield valuable information to Chemical Corps researchers. Also at Dugway is one of the processing stations for atomic wastes established by the Department of the Army. Use of the atom in the search for better sources of power, in research, in medical treatment, and in national defense has resulted in the accumulation of hazardous radioactive wastes in many areas. The Chemical Corps, in collaboration with the Atomic Energy Commission, collects and processes this waste material and ensures its effective and permanent disposal. For the safety of everyone, the wastes must be controlled. Currently, the Army Quartermaster is using the hot cell to study new methods of preserving food without the need for refrigeration. The cell is a complex installation designed for the remote handling of high-intensity sources of radiation in complete safety. I sampled meats which had been kept for many months with no refrigeration. And I'll tell you something, it was very tasty too. Next morning, I was back in Washington, my orientation finished, ready for work. Only a few days before, I had come here for the first time. And since then, a lot of doubts had been swept out of my mind. I was beginning to grasp the mission of the Army Chemical Corps, more important than ever in the era of the atom. Something else, too, about this business of CBR being uncivilized. I realized now, in the context of war with its inevitable cruelties and tragedies, CBR warfare is not the horror often pictured, if one has a true understanding of it. In any case, we must be prepared. That's the surest way of never being a target for CBR. Perhaps you can understand then why, as I stepped into the consultation room to start work, I was determined to give everything I had to the crucially important program of the Army Chemical Corps.